Hello everyone. Uh, After a long time, I'm back. My name is Ritiman. You're watching CyberTable Talks. So before we start, if you find this video useful, please like the video, subscribe to the channel, and enable the bell icons so you don't miss upcoming sessions. On this channel, you will regularly get content on Azure security, data security, and also database security and hands-on labs. Typically, every 2 or 3 videos, I will bring one focused topic on Azure security and data security weekly, along with database-related practical demonstrations. Now, today's topic is very important and very practical, which is parameterized queries and store procedures, anti-injection by design using your SQL Server. We will first understand the concept, then I will do a hands-on demo where we simulate an injection attempt and then fix it properly. Okay. So just start the slideshow. Okay. Yeah. So today we are covering how SQL injection happens in real projects and how to prevent it using parameterized queries and store procedures. I will show you the vulnerable pattern, why it is vulnerable, and then the secure pattern that you can standardize in your applications. Now, agenda is your I have cleared. Like first, we will quickly define SQL injection and why it still happens. Second, we will look at the vulnerable code patterns, string concatenations. Third, we will implement the secure approach using parameters and store procedures. And then finally, we will validate the fix and talk about best practices that you can apply in real enterprise environments. What is SQL injection? SQL injection is an attacker manipulates input. So the database executes unintended SQL statements. This typically happens when developers build queries using string concatenation, where user input becomes part of executable SQL. Now, the key risk is not only data theft, it can also lead to a data manipulation, account takeover, privilege escalations, and in some cases, complete compromise of the database and application environment. Okay. Now, why it happens? The root cause is simple: user input as treated as code. When input is concatenated into SQL text and the database person cannot reliably distinguish what is data and what is instruction. In contrast, parameters keep input as data, not code, and the database engine process it safely. Okay. Now, valuable pattern and string concatenations you can observe in the slide. So here is the pattern that causes the problem. We build a SQL statement where select where name your inverted comma plus user input. In this scenario, a single quotation plus user input, and then in that scenario, a malicious user can inject characters that alter the meaning of the query. Now in the demo, you will see how a single input can bypass authentication like checks or returns all records. Okay. Now, secure pattern and parameterized queries. Parameterized queries are secure standard because they separate SQL logic from input, and the SQL statement becomes fixed and only parameterized values changes. This also improves performance through query plan reuse and improves stability and your maintainability. Now, these are some SQL patterns that is being already I have shown you. Okay. Now, in the demo part, now we can move. Like I will do it in 3 clear steps. One is your create a simple lab database and then data. Um, Two, the second step is your run the vulnerable procedure and show how injection changes results. Okay. 3 is run the store procedures using parameters and show the same payload becomes harmless. Okay. So after that demo, I will share best practices and a checklist you can apply in your real projects. Now, what is the best practices? Basically, Like, always use parameterized queries. That is first. Avoid dynamic SQL unless necessary. If you must use it, parameterized and whitelist imports. That is very important. Use privilege list privileges. Your application account should not have excessive permissions. Log suspicious patterns and your fail attempts. Okay, always validate inputs, but remember, validation alone does not your replace parameterization. Now this is the lab I will just run. Now to summarize, SQL injection is not a legacy problem. It still happens due to your poor query construction. The fix is simple and consistent. Use parameterized queries and safe store procedures and enforce the pattern across your code base. Okay, so now we are moving to your the demo. So which will, you will observe, like first I will do what? I will set up the lab as per the instructions. So now I'm in the SQL Server Management Studio. For this demo, I will use a small lab database and simple table. Now I'm going to run the setup first script. So let's run it. Now the setup is your ready. Now create a vulnerable store procedure. So what is the store procedure vulnerable? The step second. So this is your vulnerable store procedure. Now we are gonna create it. So it has been created. Now I will move and run the your demo run book. So let's go and the demo run book. Just run. Now when I will click this normal behavior, just observe. First I will call the procedure with a normal value. Yeah, okay. So this is the normal value in the where clause. So I have crafted an input over there, and the result, please watch the result carefully. Now when I input injection payload, see the result changes. Sorry. Okay, the syntax is not correct and it should be like this only. Now if I put it like this, see the result set. Okay, instead of returning a narrow set of records, it returns far more results than intended. This is the key proof that the input was treated as code, not as data. Very important. Okay. Now, this is how attackers bypass filters and extract data, because the SQL logic itself gets altered. Okay. Now I will create a secure version. This version uses parameterization correctly, so the query logic stays fixed and only the input value changes. Okay. Okay. Then what I'm gonna do is your. Okay, I think I need to go and run the safe. This one 4.1, I think. Okay. Okay, this is the safe your store procedure. Now when I go here, demo, when I execute this, just a moment, it shows incorrect. I think this should be cleared. Hold on. Okay, just a moment. Okay. Okay, I think got it in this. Okay, safe one is this one. Okay, yeah, now it is being created. Let's go to demo. See, like when we create this like safe the same input like we have given now, this injected code is not being able to do extract any result. Okay, so the result is either no rows or only expected rows, meaning the injection attempt fails. Okay, so okay, this is not required, but yeah, this is the actually like the demo for this. Now, like whenever you will see, so whenever you, like I have shown you in the demo that whenever you will create it safely, so like their codes and parameterize safely, then safe procedure, then your SQL injection cannot harm your, or maybe it cannot data cannot be retrieved, unnecessary data cannot be retrieved. Okay, only the required outputs will be given. Okay, so like this is a very small demo I have shown it. Okay, so the conclusion is very simple. If you concatenate user input into SQL text, you create injection risk. If you parameterize your you eliminate the risk at a query construction level. Okay. Now, thank you for staying till end on CyberTable Talks. My goal is to keep security practical, clear concept, real risks, and hands-on fixes you can apply immediately. Now, if you want the lab strips and step-by-step guide, check. I will put it on the description also, and you can like see, you can ping me or you can write it the comments over there, so I can give you also. Please have a request to like the video, subscribe to the CyberTable Talks, and share it with your team. See you like in the next video, and where we will create. We will have episode on Azure security, data security, and database security engineering. So thank you and bye for now.